Hi everyone, in this video I'm just going to go over the main ideas from units 1.8 and 1.9 in Realize It. These units were very similar, so that's why I'm combining the summary in one video and in one document. So the most important thing that you need to understand is how to use the language to build a ratio and then interpret that ratio as a fraction or decimal or percent as needed. In 1.8, you focused on two quantities. Quantity 1 was the percentage of females who smoke, and quantity 2 was the percentage of smokers who are female. Initially, we talked about how these two quantities sound the same. The language is almost identical, but the order of the quantities are different. So for quantity 1, I highlighted the quantity that comes right after the word percentage, the percentage of females. So we are taking a piece of all the females, and that piece is focusing on only the females who smoke. So in the fraction you see here, we could write out what the quantities mean in words first before we translate them into numbers. So one way that we could translate that quantity is by making the denominator the total number of females. Remember, we're finding the percentage of females, so we're taking it out of all the females. We're focusing on only the females that smoke. So the quantity in the numerator would be the number of females that were smokers. And you can get that information from the table. So you had what was called a two-way table, and that table separated the members into male and female, and then smokers and non-smokers. So you can get the total females by totaling up the cells that represented the females, and then you could find the females that smoke by looking at where those two criteria overlap. The second quantity you had to calculate was the percentage of smokers who are female. That was Q2 in unit 1.8. So here I highlighted of smokers, the percentage of smokers. That is what tells you which quantity goes in the denominator. So percentage of smokers means total smokers should go in the denominator or the bottom of your fraction. Now we want to look at all the smokers and then just take out those who are female. So the people that we are looking at, what we call the comparison value, is the people who are both female and smokers. And again, you would find those two quantities by just reading the information in the table. So usually the quantity that follows the phrase percentage of is the reference value or the quantity in your denominator. So you can set up your fraction by looking for that language. Now the second thing you should understand is how to go from fraction or ratio, and that ratio can be in written form, to a fraction, to a decimal, and to a percent. So from the language, you're going to write your ratio in fraction form. If you need to write it out in words first before you get the numbers, I recommend that you do that like you see up here. But once you have your ratio in fraction form, you can always go from fraction to decimal by dividing the top by the bottom, where the numerator is divided by the denominator. The top quantity divided by the bottom quantity. That gives you the decimal. If you need to turn your decimal into a percent, then you could do that by multiplying by 100%, or you could just move the decimal point 2 places to the right. Always pay attention to how your answer should be rounded. Sometimes you're asked to round it to the nearest whole percent. Sometimes you're asked to round it to, let's say, the nearest tenth of a percent. So change it to the percent first and then determine how to round. So I gave you an example, and again, this example is similar to what you did in 1.8 and 1.9, where you had information presented to you in what's called a two-way table, or in some sort of table. In this case, we are supposing that 1,500 students in a school district were surveyed about whether they take the bus or are dropped off at school. And you see that the people are separated by whether or not they dropped off or take the bus. and by their grade level. So there are two grade categories, grades K through 5, kindergarten through 5th grade, and then grades 6 through 12, 6th grade through 12th grade. The totals here are not given, so if we need any totals, we'll go ahead and find them. We might need the total of the students who are in grades K through 5, and we could total this column. We might need the total number of students who are dropped off, so we would total that first row. The first question is, what percent of students who take the bus are in grades 6 through 12? So let's look for the of. The quantity immediately following is students who take the bus. So we want a total of all the students who take the bus to be in the denominator. In the numerator, just focusing on those who take the bus, we want to know how many of them are in grades 6 through 12. So our numerator will be of the students who take the bus, so they will take the bus, they are also in grades 6 through 12. So we want this students who fall into both of those categories. So from the table, we can get that there are 275 students who are in grades 6 through 12 and take the bus. They do both of those things, and that's the quantity that you see in the numerator, also called the comparison value. The reference value, or the denominator, is the total number of students who take the bus. And we can get this 577 by adding up everybody who's taking the bus, the 302 K through 5 students plus the 275 6 through 12 students. So once you have your quantities in fraction form, you could go from fraction to decimal by dividing. So I'm dividing 275 by 577, and I rounded that to 2 decimal places. And that leaves my final answer to the nearest percent. So I have 0.48. That's rounded, so that's why I have the approximately equal symbol here. And then going from decimal to percent, I have 48%. So 48% of students who take the bus are in grades 6 through 12. So we have another question on the same information. So the second question is, what percent of students in grades 6 through 12 take the bus? So those sound similar because we're looking at the same grade level and taking the bus, but we're comparing it in a different way. In the denominator, we have this number of students in grades 6 through 12. So we want all of the students in grades 6 through 12. So we're going to add that column together. That total is 777. We see in the denominator here. In the numerator, we still have that same quantity, the students who take the bus, who are in this grade 6 through 12. That's 275. So now we're comparing those same students to just everybody who's in that grade level. Dividing top by bottom, we have 0.35, which is equivalent to 35%. So this means 35% of the students in grades 6 through 12 take the bus. So let's just recap some of the main mathematical ideas from both of these units. From 1.8, every percentage is really just a statement about two quantities, taking two quantities and making a comparison. The numerator is called the comparison value and the denominator is called the reference value. So one of the things that you're tasked with is being able to just identify which number goes in the top and which number goes in the bottom. If you want to compare one percentage to another, either the reference values or the comparison values should be the same. So in this last example, the comparison values, the numerators were the same, 275, which represented the same quantity, students who were in grades 6 through 12 and take the bus. So we could make some comparisons over these percentages. We know that if we compare those students to the total number of students that take the bus, about 48%. So almost half of the students that are taking the bus in the school district are in grades 6 through 12. But then we could maybe think about, well, if I want to just focus on the older students in grades 6 through 12 and know what percentage of the older students are taking the bus, 35% of the older students are taking the bus. Most of the students in grades 6 through 12 are getting dropped off at school. So I could maybe talk about the comparison between those two percentages because the numerators represent the same thing. From 1.9, we thought about percentages when we talked about probability. So first, of course, we had to correctly identify the comparison of reference values like we did in 1.8, but now we can think about probability, likelihood that something is to happen. The meaning, the ratio, the comparison is still the same, but sometimes having something written in percent form or thinking about it in terms of probability helps us to understand or make predictions more easily.